What's up, team? Today we're solving equations with squares and with cubes. So a quick reminder, square root is something in the form of this. It has this radical symbol, that's the name of it. It's called a radical. So if we want to find the square root of some x value, that means we are looking for some value, let's call it y, such that y times y, where y is the same as itself, y times y equals x. So we're looking for some number that when multiplied by itself, it equals whatever's under the radical. Or another way you could say that is y squared equals x. There exists some y value such that when you square it, it equals whatever's under the radical. You've seen these a bunch of times before. Here's a couple examples. So square root of 16 means we are looking for the number that when multiplied by itself or when squared, it equals 16. And of course that's 4 because 4 times 4 equals 16. So the square root of 16 is simply 4. Let's do another example of that. Square root of 100, what times itself equals 100? Well, in this case, it's 10. 10 times 10 is 100. So those should be pretty fresh in your mind. Next, in red here, I have the cubed roots. Cubed roots, they work the same, but they're kind of a level up. So a cubed root, notice there's a little 3 up here. And technically speaking, we don't write it down every time because it's implied. It's just one of those mathy things that's true, but we don't always write it because we're all on the same page. Technically speaking, every time you see a radical without a number, there is a kind of a hidden or a secret number 2 there. We don't call it hidden or secret, it's implied. We just know that this means square root, square root, square root. If you see some other number in there, that implies that it's a cubed root. And I'm noticing here in my example, I forgot to write that cube in there. So what we're doing here is we are looking for the number, let's call it z this time, such that z times z times z equals this, whatever this number x is. So in other words, z cubed equals x. So some number when multiplied by itself 3 times equals the number under the radical. Couple examples. Cubed root of 64. What times itself 3 times equals 64? In this case, it's 4. 4 times 4 is 16. 16 times 4, that's 64. So the cubed root of 64 is 4. And you can check that real quick. 4 cubed is 64. Grab your calculator, check it out. Okay, here's a funky one, and stick with me here. Cubed root of negative 1,000. Hopefully some red flags are going off in your mind or alarm bells or whatever. You're like, hey, you can't take a square root of a negative number. That's 100% true. I mean, you can get to the complex stuff, but stuff we've done so far, we don't take square roots of negative numbers. This is not a square root. This is a cubed root. We're playing a different ball game. Same ball game, we're just leveling up. So we're looking for the number that when multiplied by itself 3 times is negative 1,000. Well, check this out. I'm going to propose the solution as negative 10. So negative 10 times negative 10 is positive 100. Negative times a negative is positive. Positive 100. Positive 100 times negative 10 now, that turns into a negative number and it's negative 1,000. So my claim is that negative 10 times negative 10 times negative 10 equals negative 1,000. And go ahead and check that on your calculator if you're not convinced. Okay, so here's kind of the takeaway from this portion. Use the square root to undo an x squared. Like say you're trying to solve for x, but it's being squared, just find the square root of it. And if you do that in an algebra situation, you got to take the square root of both sides of the equation, both sides of the equal sign. The same argument is true if you want to undo an x cubed. So use a cubed root to undo an x cubed. This one's going to take some practice. This is probably a little bit new, and that's quite all right. Let's do a couple examples and see where we can get. So this first one, 4x cubed equals 100. So the first thing I want to do is isolate all my the variables. So I'm going to get this x cubed by itself first, and then we'll deal with that. So this first move, not new at all. I'm going to divide both sides by 4. You've been doing this for years. Divide by 4, divide by 4. And what we learned, we know 4 divided by 4 is 1. 1 times x squared is x squared. So x squared equals 100. Now I'm at this point. Use the square root to undo an x squared. So that means I need to square root both sides, the equal sign being in the middle. So square root both sides. Square root of x squared is x, right? Because x times x is x squared. And the square root of 100, well, that's just 10. So the solution here, we're going to call 10. Next one. Negative 4x cubed plus 2 equals 6. Okay, got a couple steps here. We're going to subtract 2 from both sides. just like every other algebra problem we've approached prior to this. So we have 4x cubed equals 6. Nope, that's not true. Oof, okay, because 6 minus 2 is 4. Good deal, good deal. Okay, now this is gonna work out. So now we divide both sides by -4. -4 divided by -4 is 1. 1 times x cubed is x cubed. And this side, 4 divided by -4 is -1. Okay, this looks weird. This looks uncomfortable. Work with me though. So what number, when multiplied by itself 3 times, taking the cubed root here. So we're trying to figure out what number, when multiplied by itself 3 times, equals -1. Well, it's not positive 1, because 1 times 1 times 1 is 1. 1 isn't -1. That doesn't work. So let's check out -1. Let's see what happens. -1 times -1. Well, that's positive 1. Negative times a negative is positive. Times -1 again. Well, positive 1 times -1. That's -1. So the result for this one here, x equals -1. And my proof for that, or my checking my work here, is -1 times -1 times -1. Again, -1 times -1, that's 1. 1 times -1 is indeed -1. This one checks out. It's weird, it's kind of awkward, it seems like a special case, and it kind of sort of is. But the argument is true no matter how big or small the numbers get. One thing I want to point out, and this is something that's it's true, but it's kind of annoying, and sometimes it's really applicable, and sometimes it's not. But it is something we'll be picky about, especially moving forward in future years. I'm going to go back to this first example that we did, and we found the square root of both sides. We see that x is 10, and that's true because 10 times 10 is 100. Well, is there another possible solution to that? And of course, I'm asking the question, so the answer must be yes. And there is, and what it is it's -10. Because -10 times -10 is also positive 100. So there are two solutions to every square root problem. Generally speaking, we're not, as individually, I'm not as picky about that. I think it's kind of implied, but it's good to know, and I think it's important to show. So when we're solving these problems, whether on today's practice problems or on a test that's coming up, do me a solid and put this little symbol in front of your 10. And what that tells the audience, or tells yourself really, is that x equals positive 10 and x equals -10. You're welcome to write out both statements, x equals 10, x equals -10. That's just a little bit more work. So generally speaking, whenever you take a square root, you should make it a habit to say x equals positive and -10, or y, or whatever the variable is. But this little plus and minus sign says, hey, there are two solutions here, positive 10 and -10. Okay, this is how to solve equations using squares and cubes. Check out the notes, check out the practice problems. Let me know if you got questions. You got this.